mates, and welcome to this week's edition of Aspiring Athletes. I'm Sam.
And I'm Cam. Here at Aspiring Athletes, we travel all over Australia, implementing skill acquisition programs that aim to enhance skill development and learning for young aspiring athletes.
On today's program, we have travelled to the Sunshine State of Queensland to work closely with young Brisbane school footballer, Trent.
Trent, it's great to finally meet you, pal. What brings you to Aspiring Athletes?
Hey Cam, thanks for having me on the show. I've been playing in the school football team for the past 2 years in the striking position. However, in my last few weeks, my performance has been dropping due to me not being able to finish with my weaker foot. I've got state trials coming up in a few weeks, and I'm hoping you guys can help me resurrect that problem.
Trent, that's what we're here for. As always on this part of the episode, we're now welcoming Professor T, who will offer his expertise on this week's topic. Here he is, it's Pro T.
Thanks for having me back on the show, Cam. This week I've been looking at skill acquisition and biomechanics. I can't wait to help out.
Let's get started.
Before analysing Trent's kicking technique, we will provide an introduction into the framework which underpins our skill acquisition principles, the constraints-led approach. This theoretical framework uses dynamical systems theory as part of a non-linear approach to learning and skill acquisition. The different constraints as developed by Millar's model suggest that movement patterns emerge as a result of interactions between the individual, environment, and task. A constraint is a boundary that helps shape an emergent behaviour, and therefore we can manipulate constraints in a training session to encourage the formation of a desired behaviour for learners. With regards to Trent, during a game of football, constraints are constantly evolving over the course of a game and serve to channel and guide a player's actions. Therefore, the practices we implement must represent and use key information that is present during a game to guide the acquisition of motor skills.
We will now look at an example of Trent's shooting technique with his weaker foot to identify the biomechanical strengths and weaknesses. Here is Trent's initial attempt on goal. As you can see, numerous aspects of Trent's technique can contribute to an unsuccessful shot. Identifying the relevant biomechanical principles involved in this will allow us to identify why this occurs. The principles relevant in analysing this technique involve Newton's 3 laws of motion, class of levers, and torque. Newton's 3 laws of motion form the basis for principles used in sport movement. These 3 laws include law of inertia, law of acceleration, and law of reaction. Aspects of movement efficiency within these laws provide a basis for analysing Trent's technique, specifically force production, force momentum, range of motion, and summation and sequencing of forces.
Levers in the body create human body movement, such as bones, ligaments, and muscles, and the structures that are involved. There are 3 different classes of levers, with 2 sets of levers actively involved in the soccer action kick. Linked to this, torque is about generating force within the muscles to support the joints and ligaments in exerting adequate force on objects, such as the ball in soccer. The ability of force to create movement on a lever is based on the distance or lever arm that causes rotation around a fulcrum, or axis of rotation. With regards to the performance of football kicks, the mentioned biomechanical principles act as a foundation for understanding the success and failure involved in Trent's technique.
Relating this back to Trent's own technique, components of the kick can be broken down into phases to analyse the relevant biomechanical principles involved in each stage. In doing this, it provides a basis for creating tasks which look to improve the weaknesses that are occurring. The 5 stages involved in a football kick are the approach, backswing, downswing, foot plant, ball contact, and follow through.
During the approach phase, the angle and speed Trent takes when approaching the ball limits the potential for swing limb loading, as seen in the minimal hip flexion and rotation when approaching the ball. As a result, the potential velocity that can be applied to the ball is reduced. The backswing phase begins when hip flexion and knee extension simultaneously occurs. 2 levers are involved in transitioning between the next 2 phases. The first lever, beginning with the hip as the fulcrum, the thigh lever, including the glutes, hamstring as the effort, and leg lever as the load. Moving to the forward swing, a second lever arises where the thigh continues to act as the effort, the knee becomes the axis of rotation, and the ball the load to apply force on. In Trent's own technique, the incorrect timing of summation and sequencing of forces of the relevant body parts limits the range of motion for these levers and therefore contributes to an inaccurate kick. Likewise, limited shoulder adduction and upper body movement reduces potential velocity that can be forced upon the ball. These are all common aspects of a novice performer, with the pendular motion of the kicking leg having little knee flexion and no pelvic rotation. This is also relevant for the foot plant and swing phase, where the creation of torque via swing limb loading and planting the foot transfers momentum towards the ball. Trent's technique during this phase is weak because of the position of the plant foot behind the ball that limits the available force produced during the swing, contributing to an inaccurate kick. In addition to this, the weak ball contact comes from inadequate foot velocity on impact, creating an inaccurate ball trajectory angle. The follow-through and deceleration of the kicking leg decreases the transfer of the force and acceleration through the ball, linking with the angular momentum and line of impact on approach.
The negative influence of an unstable centre of gravity impacts the success involved in the movement. As we can see, Trent's centre of gravity and therefore line of gravity are outside the base of support, which contributes to an unbalanced kick. This may be because his inherent intrinsic dynamics, where he does not have an existing attractor state with the required flexibility and coordination to achieve accuracy. To improve, the centre of gravity needs to move forward and come over the ball to enhance timing and stability.
Identifying the relevant biomechanical weaknesses in Trent's kicking phases allows us to evaluate what constraints can be created to improve the movement pattern. When analysing the kick, the link between each phase and each biomechanical principle was clear.
And as such, the constraints we create need to provide relevant motor learning which doesn't deconstruct the movement. This enables implicit learning processes that are extremely vital in our skill acquisition programs, with exploration and discovery something embedded in the CLA which helps to harness natural self-organisation. So Trent, as with all our aspiring athlete programs, we set goals for our athletes in order to measure and achieve success. What are some goals that you want to achieve from the program?
Sam, my overall goal is to start scoring goals with both feet and give myself the best chance to make the rep team in a couple of weeks.
Move to us, Trent.
By applying goal and task setting for Trent during the program, it allows us to focus on setting specific measurements that rank our success. In doing so, the development of Trent's skill level becomes more rapid and creates a path towards enhancing effective motivation, self-confidence, and self-esteem. Involved in the process of creating goals is making sure that they are challenging, attainable, realistic, and specific. During the goal-setting process, we also identify that Trent is currently in stage 1 of Newell's motor learning. This is because he has not developed an adequate movement technique. This may be because his previous learning experience have not yet successfully transferred adequate skill development. This in itself acts as a challenging organismic constraint to overcome, as his prior knowledge and resulting intrinsic dynamics are poor.
Having analysed Trent's technique to identify weaknesses, set goals that he wants to achieve, and identifies he's in stage 1 of Newell's motor learning theory,
Now the best part begins, playing football.
the first constraint practice looks at creating a basic coordination pattern involved in the dynamical movement system of the kicking technique.
And this is done by manipulating task constraints and setting a task goal for Trent, which is to simply pass the ball to a receiver 5, 10 and 15 metres away. The receiver will then pass the ball back to Trent, will have a first touch and repeat the task goal again.
When analysing Trent's technique for the first constraint, the initial attempt shows similar biomechanical weaknesses previously identified during his first attempts. To assemble and acquire a new coordination pattern known as an attractor, Trent explores the interaction between the task, environment and organism constraints. As a result, appropriate movements among relevant body parts are formed to meet the task goal.
Bernstein describes this process as freezing and freeing up degrees of freedom, exploring ways to reorganize the motor system to meet the task.
Releasing mechanical degrees of freedom in this way allows the performer to take advantage of the open kinetic chain, increasing variability in the system and forming a new attractor state. In the process, specific muscle groups are constructed in a certain order, starting with the larger muscles and working down to the smallest. This process is known as summation and sequencing of forces.
When kicking, the highest amount of force comes from the hips and the least comes from the ankles. This means that a summation of force needs to start in the hip and work down through the smaller muscles and joints all the way to the foot and the ankle.
Relating this back to the phases previously mentioned, each stage in the kick has its important role to play in the correct timing and sequencing of movements. Open looped feedback after each pass from the knowledge of results and whether he achieves the task goal is critical in this sequencing, allowing Trent to self-organise through intrinsic learning. For Trent, building this attractor in the first constraint was important to be able to move out of Newell's first stage of motor learning. By unlocking the hips and allowing pelvis flexion on the non-dominant foot, it gives the ability to swing the leg more and therefore create more force to apply to the ball, creating higher accuracy when performing the pass. Although this is probably more important when performing power kicks, such as shooting, it is the same process when referring to submaximal kicking, such as passing. Therefore, correct sequencing of the larger muscles allows for transfer of greater force summation of all muscle groups.
The second constraint will look at destabilising the attractor built in constraint 1. This is done by gaining a tighter fit between the movement and the performance environment to improve control of the movement pattern.
As part of the second stage of Newell's motor learning process, this task will see Trent receive the ball from 4 different angles around the box to have a shot on goal. The task constraints embedded in this practice will see cones placed 1.5 metres inside of each post, where double points are rewarded for Trent if he scores within the cone and the post.
Various movement solutions can be employed to meet the task goal. However, more control is established through the introduction of effective task constraints. The specific goal changes and the point system act as affordances for Trent to refine his movement technique. In identifying these opportunities for action, Trent explores different angles, speed and velocity to achieve the task goal. Biomechanically, further coordination and timing of the previously stated summation and sequencing of forces promotes further control of the movement pattern. When looking at Trent's technique, the motor system takes further advantage of the open kinetic chain, allowing for an increase in the transfer of angular momentum.
The angular movement involved in Trent's movement is through segmental and joint rotations in both the sagittal and frontal planes and via the proximal to distal sequence of body parts until ball contact. Furthermore, levers in the body impact on force and applied velocity. The soccer kicking action is a third-class lever, with the hip or pelvic joint as effort, knee acting as the fulcrum, axis of rotation, lower leg as the lever arm, and the ball as the required load. In terms of Trent's movement, he adjusts lever positions to adapt to the situation, resulting in more effort applied in the lever arm, the hamstrings, glutes, and quads, and therefore greater axis of rotation to produce velocity.
A new attractor emerges from the knowledge of results provided by inherent feedback and whether his shot is placed inside the poles. Trent must identify the closed-loop information from the arriving ball and its given projection and trajectory to attune movements and relevant body parts to adjust both lever position and the sequencing of body parts. Adding key perceptual information in this way allows Trent to adjust movements to information sources that are present in the perceptual motor landscape during game environments. In doing so, the previous attractor well decays and a new attractor well emerges, which is known as degeneracy.
According to my boy Chow, degeneracy in neurobiological systems provides a number of pathways that learners could use to acquire coordination and control of isomorphic and structural constraints of movement joints.
Moving between the created attractor states, depending on the given constraints and perceptual environment, is known as metastability. Working in UL's second stage of motor learning means gaining better control of the movement. Control is achieved since different attractor states are built based on meeting the task demands that require different forces that can be applied in terms of magnitude, size, direction, point of application, and line of action. For example, different phases in Trent's technique adapt to the constraints, such as foot velocity at ball contact to move to different target positions with varied height and accuracy. Similarly, the creation of more torque via increased length of the final step promotes greater acceleration of the thigh and flexion at the knee, which creates more force.
Get your motor running. Head out on the highway.
The third constraint looks at progressing Trent's technique by working in UL's third level of motor learning and optimising control of the movement pattern.
Yeah, this practice is the same as the previous constraint, with the additional task constraints of the goalkeeper, as well as extra points added for a finish with his left foot and a first-time finish.
Adding these constraints encourages further exploration for the decay and emergence of new behaviours. Decision making is now introduced, as Trent has to make choices based on affordances in the environment. This increases the variability in the learning task, as the variant feature of the goalkeeper provides a visual perception tool for which Trent must adjust and guide functional movement solutions. A constant process of degeneracy occurs as different angles, speed, velocity and accuracy involved in the performance of the skill are exploited to optimise technique. Once again, the task constraints, the poles in the goal, one-touch finish and the weak foot finish are critical in this process of exploration to experiment with control, with more redundant degrees of freedom decaying and more refined attractor wells being produced.
Yep.
Research done by my ex-wife Ellis in 2007 reveals that by adapting the task to attain more speed when compared to accuracy means more range of motion in the movements explored.
When analysing Trent's technique, Newton's second law of acceleration justifies how the movement has improved to achieve the task goal. More force production occurs in order to gain enough velocity to strike the ball past the goalkeeper through the creation of torque and refining the movements during different phases of the kick. High knee flexion in the backswing stage provides an increased range of motion that enhances acceleration and therefore force production. This occurs because the hip limb loading transfers the force produced, and the plant foot position creates more torque. As a result, the effective striking mass, which is the measure of the body's internal contribution to the transfer of momentum, has been successfully transferred across different phases of the kick.
Yep. Research from another one of my friends, Kellis, suggests that the foot to the ball contact phase of the kick becomes important in optimizing control. Variables that affect the transfer of force onto the ball impact velocity following contact. As Trent kicks the ball with the inside of his foot, this generates spin on the ball, making the ball curve in the desired direction, away from the goalkeeper. This is what research calls the Magnus effect. So right near the ball, there is a thin layer of air dragged around as oncoming streams pass the ball. In a normal kick, the ball is struck in the middle of the ball. The ball travels in one direction, while air and wind travel in the opposite direction around the ball. Gravity then pulls the ball down into the goals. This airflow can be manipulated by kicking the ball at different angles. Since the contact of the ball is now on an angle, this imparts spin on the ball with the airflow around it flowing in different directions.
Get your motor running. Head out on the highway, looking for adventure, and whatever comes our way. Yeah.
Achieving this state of metastability allows Trent to move between different attractive states, such as movement patterns between both feet depending on the given perceptual information and affordances.
Now, this is evident in Trent's later attempts during the activity, where he uses both feet and uses different techniques to score past the goalkeeper. In setting Trent up for future success,
The third constraint aims to make him a dynamic learner and intelligent performer that can move between these different attractors depending on opportunities offered during game situations. See you again, mate. What's been happening since last time we saw you?
Sam, I'm now the top goal scorer in my team, scoring with both my left and right feet. And it turns out I made the state team this week.
That's very good to hear, mate. And what about some goals and motivation for yourself?
Obviously, I learned a lot in the program. Definitely improved my technique.
Yep.
And that has also helped me improve my motivation to take my football to the next level.
Trent, proud of your progress, mate. Another product of aspiring athletes.
Work it, make it, do it, makes us harder, better, faster, stronger.
That don't kill me, can only make me stronger. I need you to hurry up now, cause I can't wait much longer. I know